That's going to be the goal, is to finish our absolute value notes, get a couple of practices in with a GED practice question, as well as the practices that we have to do for this week. We're going to review those. And that's really it. I think that's really the plan for today. We're going to make sure that we're nice and ready to finish up week 5 strong and prepare for week 6 worth of content, which is going to be next week. All right. Okay, so very good, Jules. Yes, yes. So starting off with this practice question, it says 2 points are plotted on a number line, negative 11.2 and 3.3. What is the distance between these 2 points? And very good, Jules already figured it out, that the distance, again, because distance is neither negative nor positive, we just have to figure out how far the 2 points are from 0 and add that together. And then that distance is going to be 14.5. Very good. Sorry, 1 second. The teacher's having an issue with Cami, but we're going to get right into the notes. So go ahead and open up your notes in Schoology. Let me switch to Schoology now. We're going to open up our notes in Schoology, and we're going to continue working on our week 5 notes. Okay, so I'm going to go to Schoology now. All right, so we're in Schoology. We're in Math Skills 5. All right, we're going to go to week 5, integers, and we are going to open up our integers and absolute value notes. All right, this was the recording from Monday, so if you weren't here on Monday and you need to see that video, make sure you click on that video so we can help you with those notes, and we're going to finish up the last page of notes today. Okay. All right, so make sure you have your integers and absolute value notes turned on. And we're going all the way to page 4 because that's where we left off. And we are going to go over, starting with example 2. We're just going to redo example 2. We're going to do examples 2, 3, 4, 5, 6, and 7 today to get ourselves through these notes on that last page. Okay, so here we are with example number 2. I'm going to go ahead and get started here, and we're going to work through this example. So what we have here is a equation that has a positive answer, right? So we have
Yes.
we have a positive answer here. So that means that we can proceed. It should have 2 answers, but to make sure, we need to isolate the absolute value and the answer. So the way to do that is I need to add 3 to both sides first. And Jules already saw this on Monday. That's okay. We're just going to finish up these 2, and then we're going to move on to the other ones. So we have 3x minus 4 is equal to 14. Once I have that, once I have the absolute value isolated on the left and the answer answer isolated on the right, that should be good enough, right? Like now I know that I can proceed and I will have 2 answers. And because I know I have 2 answers, what I need to do is split this into 3x minus 4 is equal to minus 4. I don't know why I wrote minus 4 is equal to 14. And 3x minus 4 is equal to negative 14. I have to do the answers for both without the absolute value. So I will solve both of those, which gives me 3x is equal to 18. Divide both sides by 3. One of my answers or my solutions for x is equal to 6. And then add 4 to both of those. So then it's 3x is equal to negative 10. Divide both sides by 3. And now x is equal to negative 10 over 3 is the other answer. So I'm going to have 2 answers, right? There's 2 solutions whenever I have this set up where I have the absolute value is equal to a positive number. I always have 2 solutions.
That's it.
Okay. And then we'll do example number 3, and we're going to do it the same way. We have to isolate the absolute value, get it by itself, and then get it equal to a single answer. So we need to subtract 5 from both sides. That's going to give me 2 times the absolute value of 2x minus 5 is equal to 6. I need to divide out the 2 from both sides. And that's going to give me the absolute value of 2x minus 5 is equal to 3. And again, I'm going to split that into 2. 2x minus 5 is equal to 3. And 2x minus 5 is equal to negative 3. And I'm going to solve both of those. So I add 5 to both, and I get 2x is equal to 8. I divide both sides by 2. X is equal to 4. That's one answer. Add 5 to both sides over here. I get 2x is equal to 2. Divide by 2.
All right. Y'all have a good day.
All right, so those are my 2 solutions for example number 3. Okay, x equals 4 and x equals 1. All right, so anytime my absolute value is set equal to a positive number, I'm going to have 2 solutions for my value of x. Anytime my absolute value is set equal to a negative number, I'm going to have no solutions. And anytime my absolute value is set equal to 0, the answer is going to be 1 solution.
I gave it to you.
All right, so that's how that's going to be set up. All right. So now let's get into the ones that we haven't seen on Monday. We already talked about how Monday's class ended. Let's get into the ones that we haven't seen yet. We're going to do examples 4 through 7. Okay, so we're going to start with example number 4. Right, so right now, this absolute value is being added to 4. I need to get it away from that 4. So I'm going to subtract 4 from both sides of the equal sign. That's going to cancel out the 4 in both places. So now I have 2x plus 1 is equal to 0. So because it's equal to 0, I know that I'm only going to have one solution. So what that means is that I can pretend that those absolute value marks are not there. Okay. And I can just do 2x plus 1 is equal to 0. I will subtract 1 from both sides. So 2x is equal to -1. Divide both sides by 2. And my answer is x is equal to -1/2. Okay. That is the only way to get a solution that works for number 4. So there's only one solution. X is equal to -1/2. Whenever my absolute value is equal to 0, I'm only going to have one solution. Okay. For example number 5, Jules, can you walk us through how to do example number 5? Where do I start?
For number 5, okay, absolute value of 2x -5 plus 9 equal 9.
Yep.
The first thing is to add -9 on both sides.
Okay, good. So I'm going to subtract 9 from both
on both
sides.
sides. Yeah, that's mean now.
Good. So I have 2 times 2x minus 5. The absolute value of 25 is equal to 0. Okay.
Okay. But now, when it's equal of 0, we just have one solution.
Okay, good. So I should get rid of this 2 first. I am only going to have one solution. You're correct. Wait to get rid of this 2. So I have to divide both sides by 2, and 0 divided by anything is still going to be 0. But yeah,
0.
I still need to do that. So 2x minus 5 is still equal to 0. And like you said before, I only have one solution. Good. Right?
Yeah.
So 2x
minus 5 equals 0.
Okay.
2x equals 5.
Good. So 2x is equal to 5.
5 and x equal to 5. 5 over 2. Yeah.
Yep. 5 over 2 or 5 halves.
5 half. Okay.
Yep. Very good. Okay. So 5 halves is going to be my only answer here. To get that 0. Perfect. All right. So both of these examples, example number 4 and example number 5, only had one solution because our absolute value was equal to 0. And whenever that happens, we only have one solution.
Sure.
All right. Very good, very good, very good. We're going to look at the next set of problems, 6 and 7. The last 2 actually in our examples. All right. So for example number 6, I want to again try to get the absolute value by itself. If I get that by itself with the equal sign in between it and a solution, then I can see what I need to do. So first thing is I'm going to subtract 7 from both sides of the equal sign. That's going to cancel it out here. And then I have 3 minus 7, which is going to give me -4. So -4 is equal to 4 times x, the absolute value of x minus 1. Again, the absolute value is not by itself yet because there's a 4 here. So I need to divide both sides of the equal sign by 4. So now I have the absolute value of x minus 1 is equal to -1. Okay. All right. Now the absolute value is by itself. So now I can make some decisions. Because the absolute value is equal to -1, I know that I have no solution. Anytime your absolute value is equal to a negative answer, you have no solution. So you can just stop. That's it. You have no solution. So example 6, there is no solution. Why? Because your absolute value is equal to -1. Whenever your absolute value is equal to a negative, there is no solution. Okay. All right. Who wants to try number 7?
I can try number 7.
Okay.
5 minus absolute value of 2x -3 equals 7.
Good.
Does mean I divide both sides by subtract both sides with -5.
Yeah, you have to subtract 5 from both
Yes.
sides first.
Yeah.
Okay, so we have the negative absolute value of 2x minus 3 is equal to 2. Okay?
Equal to 2, yeah. And now but then the negative in front of the absolute value, I have that mean it's going to be like minus 2x plus 3.
So actually what that means is I need to divide it out. So I need to divide both sides by -1 to get rid of it. So it's going to cancel it out on this side.
Okay.
Now I have the absolute value of 2x minus 3 is equal to -2.
Okay.
So now what does that mean? It's equal to a negative. So what does that mean?
That does mean there is no solution.
That means there's no solution. So there's no solution for number 7 either.
Okay.
Okay. So anytime your absolute value is equal to a negative number, you're going to end up with no
Solution. Okay.
Okay, good work. All right, so those are the notes. So our notes are now completed for this week, right, on integers and absolute value. The videos cover both notes, and after I finish uploading it today, you'll have both versions of your notes ready, both videos to do your notes ready. Make sure you review these videos. They're very helpful when you review them and you go back and look at them. And they're always in your folders as well. All right, so what we're gonna do now is like look at some of the practices that you guys have to do for this week. and we're going to review that work so that we are comfortable doing the work that we need to do for this week. So I'm in your Schoology folder in week 5, integers and absolute value. All right, and so what I'm going to open up first is practice number 1, right? Practice number 1, if you're watching this video back, is what needs to be turned in. If you're here with me live, you guys are good. We're going to work on it together. But practice number 1 is what should be turned in today. All right, so I'm going to open up practice number 1, solving absolute value equations. Okay, so here we go. So number 1 is the absolute value of x is equal to 10. So in this one, we already have, we have a positive number as our answer, and the absolute value is already isolated. Because I have a positive number, I know that I have 2 solutions. Good. So that means I have to do x is
equal to
10, and x
equal to negative 10.
10. That is my answer. Okay, x is equal to 10 or x equal to negative 10. Because when I put that 10 inside of the absolute value, my answer is going to be 10. When I put negative 10 inside of the absolute value marks, my answer is still going to be 10. So those are my 2 solutions for number 1. X is equal to 10 and x is equal to negative 10. Very easy, very straightforward, a nice, good way to start. All right, number 2 is the same thing. We already have the absolute value isolated. It's by itself on the left, and then by itself on the right is the answer, and the answer is positive. Because the answer is positive, I know that I have 2 solutions. So that means I need to set it up as x minus 5 is equal to 2, and x minus 5 is equal to negative 2. So I remove my absolute value marks, and I set it up just like this. And now I solve for x. To solve for x, I just need to add 5 to both sides. So one answer is x is equal to 7. And the other answer is x is equal to is equal to 3. Negative 2 plus 5 gives me 3. So those are my 2 answers. X is equal to 3 and x is equal to 7. Those are my 2 answers for number 2. To check my answers, all I have to do is put them back into the absolute value to see if it works. So let's try it. 3 minus 5 in absolute values is equal to 2. Is that true? Well, let's see. 3 minus 5 gives me the absolute value of negative 2, which is in fact 2. That works. Let's see. 7 minus 5 is equal to 2. 7 minus 5 is 2. So yep, that also works. So if you want to check your answer, you just plug it back in to the absolute value. Just like you would do for any other equation, when you get an answer, you plug it back in to see if it works. So the answer to number 1 and the answer to number 2, that's it. All right. I'm going to do one more. All right. Again, this one, the absolute value is already isolated. It's already by itself. And my answer is also by itself and it's positive. So I know that I have two solutions because my answer is positive. So I remove my absolute value marks and I have just x plus 6 and I set it equal to 4, but I also have to set it equal to -4 and then solve for x. When I solve for x here, because I'm adding 6, I need to subtract 6 from both sides of the equal sign. It's going to cancel out here. I'm going to get x is equal to -2. And then I'm going to again subtract 6 from both sides on this version. And I'm going to get x is equal to -10. So those are my two answers for number 3. X is equal to -2 and x is equal to -10. In number 4, my answer is a -3. Whenever my absolute value is isolated, but my answer is negative, I have no solution. So I do not need to do any math. You just have to write no solution. So there's no solution for number 4. In number 5, my absolute value is isolated and it's equal to 0. There's only one solution. In this case, that solution is 0. So x is equal to 0. It's the only solution for number 5. All right, so those are numbers 1 through 5 done for you. And that's how we do it.
The number 6.
Okay, yes, we can go on to number 6. Let me move it up and delete my drawings. Okay. Okay, number 6. You want to walk us through number 6, Jules? What do we do?
Yeah, for number 6, absolute value of 2x minus 1 equal to 9.
Yep.
I I divide both sides by 1.
Yep, so I have to add 1 to both sides. Okay. Now you have 2x is equal to 10. Okay, great. So now you have your absolute value isolated. So you know that you have a positive solution. That means you have two solutions. Okay, great. Oh, I lost you. I can't hear you.
2.
Okay, good. So you have 2x is equal to 10, and 2x is equal to -10.
Yeah.
Right? And so to solve, you just divide both of these by 2. So one solution is x is equal to 5, and the other solution is x is equal to -5. Okay. So x is equal to 5 and x is equal to -5 are your two solutions for number 6. Okay, but first things first, before we can do anything, is to isolate the absolute value. To isolate it, we have to get rid of this 1 that's being subtracted. How do we get rid of a 1 that's being subtracted? We must add 1, right? So that's what we did. We added 1 to both sides of the equal sign. We ended up with 2x. The absolute value of 2x is equal to 10. Because we have 10, a positive answer, we know that we have 2 solutions. So we have to split it into a positive answer and a negative answer and solve for x. Very good. Miriam, are you on with us? Can you hear me? I see your name.
Yes, I'm on, Mr. J.
Oh, okay. Great, great, great. Woo. Okay. So if we look at number 7 is already isolated, right? We don't need to do anything extra to isolate it. And we have a positive answer. So we know that we have 2 solutions. Because we know we have 2 solutions, we have to solve it with a positive 10 and a negative 10. So we do 2x minus 1 is equal to 10, and 2x minus 1 is equal to negative 10. So what are my 2 solutions?
The first one, x equal to 11.5.
Okay, so x is equal to 5.5 is 1. And x is equal to negative 4.5 is the other. Okay. So the biggest trick with absolute value is remembering when we have 2 solutions, and we have 2 solutions whenever we can isolate the absolute value and it's equal to a positive number. All right, so these are equations, and none of those rules change when we switch to inequalities. The rules stay the same when we switch to inequalities, okay? None of the rules change when we switch to inequalities. It's all the same. So we're going to look at the inequalities next. Okay, so here, we're not going to have to do a lot of work here, right? But it says x is less than or equal to 5, right? X is less than or equal to 5, right? So what values of x is going to make that work? Well, whenever x is 5 or -5, right? So the answer to this is anytime x, oh, sorry, let me put it in a different place, right? Because it's less than or equal to, right? When is this absolute value going to be less than or equal to 5? It's going to be anytime that x is less than or equal to 5, or whenever it is greater than, no, I don't want to write this, less than or equal to -5, right? Yes, -5 needs to be greater than or equal to x. I need to write this the right way. Excuse me. Yes, this is right. Okay. So it can't be anything less than -5. It can't be anything greater than 5. Because anytime that it falls outside of this range, it's not going to apply here, right? So if it is less than -5, so if it's -6, if I put -6 in here, it's not going to satisfy this answer, right? Because the absolute value of -6 is 6. 6 is not less than or equal to 5, right? So that means that x needs to be greater than or equal to -5, but less than or equal to 5. That's the range in which it satisfies this answer, right? If x is any smaller or any bigger than 5, the absolute value of x is going to be greater than 5. So we need to make sure that we keep it in that range. Okay. So when we do the answers for our absolute value, we're going to have ranges now, right? Where we're going to have values that look like this, where we have a value before and after the x, right? It's going to be very similar answer for number 9, which is that we're no longer going to use the equal to. It will just be -5 is less than x, but x needs to be less than 5. So that means the only place that x can exist, if I were to put that on a graph, on a number line graph, the only values that x can be is in between -5 and 5, right? So it's only in this range are the values of x okay. Anything outside of that range, x cannot be, right? That's what both of these mean essentially, is that x can't fall outside of this range, because when it falls outside of this range, it no longer satisfies this answer. So it has to be in between -5 and 5 for number 9, and it can be equal to and including -5 and 5 for number 8. Okay. For number 10, we have a negative answer. So what's our answer? Is there any way that you can put any number in this absolute value and get a negative answer out?
No solution.
So again, just like when we have an equal sign, right? Whenever the answer for our isolated absolute value is equal to a negative number, there is no solution. We can never make an absolute value equal to a negative number. Absolute value is always positive because it's measuring distance. Okay. So we're going to get our range for number 11 by solving like we would solve for an equal sign or an equation, right? Is we're going to solve this inequality just like we would do an equal sign. So we're going to pretend that there's an equal sign here, but then we're going to use this sign to give us our range. So our absolute value is already isolated and we have a positive answer. So we know that we need to do x minus 4 is less than or equal to 3, and x minus 4 is less than or equal to negative 3. So we're going to add 4 to both sides, and then x is less than or equal to 7. Add 4 to both sides, and x is less than or equal to 1. So that is going to give us our range. So that means our range is 1 is less than or equal to x, which is less than or equal to 7. So that's the only range in which this would satisfy that answer. If x is 1 or x is up to 7, that's the only way that it's going to be less than or equal to 3 as the answer. So your smaller number needs to always appear on your left in these cases, and your larger number needs to always appear on the right. 1 is less than or equal to x, which is less than or equal to 7. To see if that works, I'm going to change my color and I'm going to plug it in, right? I'm going to plug in 1 as my value here. So when I put in 1 minus 4 is going to give me negative 3. The absolute value of negative 3 is 3. Is 3 less than or equal to 3? It is, so it works. Let's try another number, right? Because it's any number in between 1 and 7, right? That's what this says. Let's try the number 3. Why not? Let's try 3. Because 3 is in between 1 and 7, right? So what is the absolute value of 3 minus 4? The absolute value of 3 minus 4 gives me negative 1. What's the absolute value of negative 1? It is 1. Is 1 less than or equal to 3? It is. So it works. Okay? Any number in this range is going to work. If we go outside of that range, it's not going to work. And I will show you that it won't work. So 0 is outside of that range. Let's put 0 in as one of our answers. So let's do 0 minus 4. Right? 0 is outside of that range. So 0 minus 4 is actually going to give me negative 4. The absolute value of negative 4 is 4. Is 4 less than or equal to 3? It is not. So 0 doesn't work. Okay? Only the numbers inside of this range is going to satisfy this absolute value. Okay? So that's what we're working on. That's what we're doing to get these answers. Let's try number 12. Again, number 12 is already isolated for us. So all we need to do is set up our 2 possible answers. So we need to do x plus 4 is less than or equal to 1, and x plus 4 is less than or equal to negative 1. And we need to solve for x in both cases by subtracting 4 from both sides. So x is less than or equal to -3. Subtract 4 from both sides here. X is less than or equal to -5. So that means that our solution needs to be -5 is less than or equal to x, which is less than or equal to -3. So the only numbers that work is when x is within that range. So this is our solution to number 12. And we're going to check it by plugging in 4, -4, as our answer. Let's see if -4 works. -4 plus 4 is going to give me 0. The absolute value of 0 is just 0. And 0 is, in fact, less than or equal to 1. Right, so this works. This range is the correct answer for number 12. Since number 13 is visible, we'll go ahead and do 13 too, because it's actually pretty easy. It's just 3, and we have x. So we know our answers are going to give us -3 and 3. So we're going to say x is greater than or equal to 3. So we have it that as long as x is in between that range.
The sign is different. Is greater than, greater or equal?
Oh, that's right. The sign is different. I need to change my sign. My sign needs to change. So my sign needs to go the other way. So basically what I'm saying is that x needs to not be in between -3 and 3. It needs to be a number smaller than -3 or it needs to be a number that is larger than 3.
Okay.
Right? So -3 is greater than or equal to x, and x needs to be greater than or equal to 3. So it cannot be, what I'm saying is that x in this case x cannot be any of these numbers. I can't have any of the numbers in between -3 and 3. Because if I put any of those numbers in here, it's not going to work. Right? If I put in 1, 1 is not greater than or equal to 3. But if I put in 4, 4 is greater than or equal to 3. So it can't be the range inside here. Right? So -3 is greater than or equal to x. So x has to be less than -3. Or x needs to be greater than or equal to 3. I can't have x inside the range of -3 to 3. Mouse, scroll down. We're gonna do numbers 14, 15, and 16. Okay, again, we have an absolute value that is set equal to a negative number. So we have no solution. Okay. But number 15 we can do. So we're going to do x minus 2 is greater than or equal to 4. And x minus 2 is greater than or equal to negative 4. We solve by adding 2 to both sides. X is greater than or equal to 6. Or x is greater than or equal to negative 6.
Mr. G.
Yep.
So we don't change the sign in here, the greater than to less than?
And yes, I'm sorry, here on this, on the left side, it should be less than, you're right. So x needs to be greater than 6 or less than negative 6. So it should read like this. Yes, greater than.
I got a question.
Uh-huh.
How do you have -6?
Oh, sorry. 2
Yes, -2, yes. It's -2.
is when you're rushing. See what happens when you rush? I tell y'all not to rush all the time. And here I am rushing, making all kinds of mistakes. Okay. So we're adding 2 to both sides. And so it should be x is less than or equal to -2. So this should be -2 here. So the range is -2 to 6 that we can't have. Okay, any number in between -2 and 6 and +6 cannot be an answer. As long as x is less than -2 or greater than 6, then it is a solution to this one, to this problem here, number 15. Okay, and to make sure that that works, we can see that 0 won't work when we plug it in. 0 should not work, right? 0 minus 2 is going to give us -2. Yep.
So we had x is equal to or less than, but here we have, for the answer, you have -2 greater than x.
So
right.
x should be less than or equal to -2. What does it say here?
It says
-2 should
yes.
be greater than or equal to x. That's the same thing. Right? Where's the mouth? The mouth is toward the -2 here. Where's the mouth here? It's still toward the -2. Okay. I just switched the places, but it's still the same. It still says the same thing.
Okay.
Yep. Good question though. Yeah. Okay, so we can see here that 2 is not greater than 4. So 0 doesn't work. Any number in between this range is not going to work. But a number outside of this range, like 7, should work. So if I do 7 minus 2, I'm going to get 5. And 5 is greater than or equal to 4. It works. Okay. So yes. -2 is greater than or equal to x, and x needs to be greater than or equal to 6. All right, our final one, we're going to set up as 2x plus 1 is less than or equal to 3, and 2x plus 1 is greater than or equal to negative 3. We're going to subtract 1 from both sides. 2x plus 2x is less than or equal to 2. Divide both sides by 2. X is less than or equal to 1. That's the first solution. Subtract 1 from each side over here. We have 2x greater than or equal to negative 4. Divide both sides by 2. X is greater than or equal to negative 2. So the range for number 16 this is for number 16. So it needs to be a number in between the negative 2 and the 1 for it to work. The number 16. X is less than or equal to 1, greater than or equal to negative 2. All right, so this means that this week we did our first introduction to algebra work, right? We've been doing a lot of review beforehand, did a lot of review of our decimals and our fractions to make sure that we're ready. But this is algebra. We've dived right in. Okay, so we're now face first into our algebra. We're working through these inequalities with the absolute value and these equations with absolute value. And we're gonna, it's just gonna keep rolling from here, right? Just more and more algebra after this. So I wanna do another practice with us since we have time. I'm gonna go into another practice. This practice number 1 that we just completed all together, this, if you're watching this back later, this is what needs to be turned in by 7 o'clock for you guys to get credit. Everybody that's already on here with me is getting credit for this already, because I know you did it because you did it with me. But if you're watching this back later, make sure this is turned in today by 7 p.m. Wednesday to get credit. I am going to go over the other assignment that needs to be done today to also get credit. So I'm going to go over that right now, and I'll start that right now. And then you guys need to finish it by 7 o'clock tonight. All right. So in our Schoology, in our week 5 folder, you have a couple options. You can do the IXL practice or the exit ticket by 7 p.m. tonight to get credit. Okay, I'm going to just demonstrate what the IXL practice is. I've just put some links in Cami for you guys to work out. All right, so any of those, we're just going to click into it. I have to, of course, sign in because I'm not signed in. I never sign in, I don't know why. But we're just going to be doing the same thing that you were doing before. We're going to solve these absolute value problems. all right? With these, yes, absolute value problems. And so we're gonna get a range here as well. We're gonna do -2, we're gonna get 0. That's one of the solutions. And the other solution is going to be -4, right? So those should be the answers. You click submit and you get it correct. Woohoo, right? So practice on here. Of course, if you get it wrong, I'm going to just choose 2 random answers. And when I get it wrong, they will explain what I need to do, right? X equals A or X equals -A. So I need to solve it and they'll show me what I need to do. The only answer is 4, okay? All right, so that's it. So those are what you need to do to make sure you get credit for today. You have 2 options, as I said. Do practice number 3, which are your absolute value IXL links. Do all 3 of those, or you can do the exit ticket. But of course, the exit ticket covers everything. And if you're not as familiar with everything yet, maybe you want to do the practice in the IXL first. So I definitely suggest that you do the IXL. You have all the rest of the day today to do it, please do it. What I'm going to go over now are the word problems in practice number 2. Okay, both versions of these are the same. One is PDF, one is a Word doc. I'm just going to open up the PDF and we're going to work on that. So we're looking at practice number 2 right now. If you guys want to follow along, it's practice number 2 in your folder. The absolute value word problems. That's what I'm working on right now. All right, and so there are just 6 word problems. We're going to try to do them all and get them done today. I guess this is another option for you all who are watching the video back. You can do this or practice number 1 for credit for today. I suggest you do both because we're about to finish both. Okay. So the word problem, it says the average monthly temperature in a northern Canadian city is 1 degree Fahrenheit. 1 degree, you read that correctly. The actual January temperature for that city may be about 5 degrees Fahrenheit warmer or colder. So what is the range of temperatures? In order to find the range of temperatures to solve the absolute value problem. So that means we are going to do this absolute value equation. Except Mr. P has lost his pen. So give him a second. Where'd my pen go? Oh, it's in my lap. Okay. All right, so we're gonna solve it. We have t minus 1 is equal to 5. So the absolute value is already isolated. So I just do t minus 1 is equal to 5 and t minus 1 is equal to -5 to figure out my range. And then I solve by adding 1 to both sides. So t is equal to 6 and t is equal to -4. All right. So my range of temperatures, right, is anywhere from -4, right, to 6. That's my range of temperatures. I'm looking for a range of temperatures. That means my answer is probably going to be written as an inequality, right? So X can be greater than or equal to -4 or less than or equal to 6. This is the range of temperatures in Fahrenheit for this Canadian city, right? I'm going to write it horizontally so it can be read easily. So that temperature can be anywhere from -4 degrees Fahrenheit to 6 degrees Fahrenheit. That sounds terrible. I can't believe people live there. I would never do it. Couldn't do it. No way, no how. I'm cold just thinking about it.
Mr. G,
Yes.
How did you get the lesser than or equal to?
Very good. So based on what was said in the paragraph, right? It says that using this equation will tell me the range of temperatures. Whenever I see the word range, I know that I'm going to be using
The greater than or the
inequality.
lesser than. Oh.
Okay, that's why. Right. So the other way to say it, right, because it's looking for a range, I know it has to be those. If it just asks me for what is like the minimum and the maximum, then I would just see the maximum is 6 and the minimum is -4. But it wants the range. So I know that my temperature can be anywhere from -4 to +6.
And because it's negative, that's why we have less than.
So I have, so what it says is that it's -4 is, so what this is saying is that X is greater than or equal to -4, but less than or equal to 6. That's what it's saying, right? You have to read it from the perspective of X because X is in the middle. So right now it says X is greater than or equal to -4. So it can't be anything less than -4. And it must be less than -6. It can't be anything greater than 6. The only reason I'm using these less than symbols is to indicate that X can't be anything lower than -4. That's what's happening here. I'm not going anywhere lower than -4. I want you guys to try it. Okay, so I have 2 more examples. I'm going to erase this example here and I'm going to move this up. So I have numbers 2 and 3. I know Tashelle is still connecting. It's very weird what's going on with Tashelle's computer. I'm not sure. But I have numbers 2 and 3. And I want, oh no, number 3 is not a real word problem. All right, so here we're going to do number 2. I'm going to have Jules try number 2. And then I'm going to get another one for you to work on, Miriam. You can also do number 2 as well, Miriam, but I want
So
Jules
the temperature of an enclosure for a pet snake should be 80 degrees Fahrenheit. Give or take 5 degrees. Solve A minus 80 = 5. Find the maximum and the minimum. Shucks. Mr. G.
Don't worry, Jules is going to give us the answer for this one. But you can still work on it. But I want Jules to.
Only 2 of us in class?
Well, Tashelle is here, but it still says connecting. It's for whatever reason she's not really connected to class right now. I'm not sure what's going on.
Okay.
Oh Lord. So this is gonna be a positive.
So I'm not sure if you said something, Jules, because you're very quiet. For whatever reason, it sounds like you're very far away.
Oh. Okay, for the number 2.
Mm-hmm.
Okay, for number 2, the absolute value of A -8 = 5.
Yep.
Okay, the first thing to do, I know that I will have 2 solutions.
Right, you have 2 solutions. Very good.
A minus 18 = 5. A minus -5.
Perfect.
Okay, for the first one, I add area on the both sides. A began 85.
Good.
On the other side, A began 55. 75.
Okay, good.
The maximum temperature is 85 and the minimum is 75.
All right, very good. So I'll summarize what Jules said because he's a little far away, but because we have the absolute value, it's isolated, and we have a solution that is positive, we're going to have 2 solutions, right? So we have to do both the +5 and -5, and then we just solve. And so the maximum temperature is going to be 85, right? And the minimum temperature is 75. And because it asks for a maximum and a minimum, I don't have to do a range here, right? I don't need to do the inequalities here because they're not asking for a range. They just ask me what the max is and what the minimum is, all right? And so I found that using the absolute value, okay? So that's why I have these two solutions, because I have a positive, whenever you have a positive answer for your absolute value equation, you're always gonna have two solutions. All right, and because it asks you to find the max and the min, you can identify both of those. All right. All right, let's scroll down to number 4 so that we can get a problem for Miriam to work on. Number 3 was a think aloud. We'll skip that one for now. Okay.
Temperature
Right.
average 40 degree last month. Temperatures were about 10 degree warmer or colder, right? And solve an absolute value equation to represent the situation. So it says the average is 40 last month. Temperature were 10. So that's equal to 10. Temperature were about 10 degree warmer or colder. That means we're going to use less than or equal to. Right, this right hand side absolutely equal to representing the solution. Okay. So I can use any value at the front, right?
You can use any variable you want, but let's take a look back at some of the ones that we did before, right? So just to look at number 2, it says the temperature of the enclosure should be about 80 degrees, right? And you give or take 5 degrees, right? Okay, so just kind of showing you what that looks like. Okay, so now what would you do for yours?
I have B. Take away 40 equal 10.
Okay, right. Don't forget your absolute value, right? Absolute value of B minus 40. Good.
Right. I didn't remember that.
10. Very good. Okay.
So it's gonna be plus 40 here. I have it on both sides.
Right. Good. Don't forget you need to do it with the negative 10 as well, right?
Right, I have it, yeah. One is positive, one is negative.
Excellent. So you split it now into those two.
So that's going to be 50. So B equals 50, and then 40, negative 40. So that's going to be negative. No, that's positive 30. So that's going to be 30.
Perfect. Okay.
So B equals negative 30. Not negative, just 30. Lord, I got that part wrong. So it's 30. So it's gonna be right the value of the absolute equal to represent the situation. So it's gonna be B. Oh, you write it already.
Yeah, but this is good. So you did this part where it asked you to write and solve the equation. This is right. This is good. Right? It doesn't ask you to do this part. This part I added because you were right. You were already thinking about this when you saw that it was going to be a range of temperatures, and that's correct.
Right.
If they wanted you to write what the range of temperatures were, this is what it would be. But they didn't ask you actually to do that.
The third would be at the front, but I was going to write the B equals 30.
Yeah.
B equals 50, but I don't need that. I need to just put the B in the middle and write
the range of temperature.
Right.
Yes, very good. This is it. Yeah, this is it. You guys are doing well. Yeah. I thought this was going to trip you guys up. I thought you guys were going to have problems with this, but this is good. Very, very good.
But what if it was supposed to be a positive?
What do you mean?
How would it be stated if it was supposed to be a positive?
What do you mean? If what was supposed to be a positive?
All right, like we have the B negative 40.
Uh-huh.
Could
I
it
see.
be?
I see what you're asking me. Yeah, so in so what we're working with here, it's always going to be, we're always going to represent it with a negative like this because we are trying to figure out if 40 is the average, but it can go up 10 more, right? That means the highest it's going to be is 10 above it. So it's going to be a subtraction of 40, right? So it's going to be 50 minus 40, right? Because we're always going to be looking for the maximum. So the maximum is always, we're always going to be subtracting the average from the maximum. So it's always going to be written like this as a negative. When we're looking at these absolute value equations that we have to make ourselves, we're always going to be looking for it that way. The situations in where we were doing a positive are few and far between. But it most likely always going to be a negative because we're always going to be working from an average, which needs to be subtracted from the biggest number. Okay, so let's look at number 5 because we're going to see again we're working with another average here. So it says scores on the final exam averaged 85%. The scores were about 7% higher or lower. So now let's write another absolute value equation to represent that situation.
So it would
Very
be
similar.
A negative 85 equals 7.
Okay, the absolute value of, yep.
Oh, Lord.
Don't forget that. Yes, you need the absolute value. But yes. Okay, A minus 85 is equal to 7. Again, we have the absolute value and we have a positive answer here. That means we have 2 solutions. So we need to split it into A minus 85 without the absolute value is equal to 7. And A minus,
you said?
I'm sorry?
Without without on the other side, when it's negative, it's only one absolute value.
When it's negative, the answer is no solution. If this was equal to a negative 7, there would be no solution.
No solution, right?
Yeah. Okay, so now we have A minus 85 is equal to 7 and A minus 85 is equal to negative 7. We have to solve the A in both cases by just adding 85 to both sides.
So from 85 would be 88. So what I'm saying, 78. 78. 78. So A equals 92, A equals 78. A 78. What I'm saying, not 78, sorry. 15, we had 78, right?
Mhm. So that means my highest score on this test was a 92. My lowest score was a 78. And this is my range of scores here, right? In between a 78 and a 90, and oops, not an 85, sorry, a 92.
92.
I just said it, but wrote 85 anyway. All right, questions about these?
I mean, with more practice, you'll get it.
Yes, yeah, we're gonna do number 6. That'll be our last one, and then we'll check back in. Let me clear all of these. Okay, last one, number 6. The average time it took a group of students to run a mile is 9 minutes. Times were about 1 minute higher or lower than the average. Write and solve an equation to represent the situation.
So the average time it took a group of students to run a mile is 9 minutes. So that is 9. Times were about 1 minute higher or lower than the average. So we're dealing with average again. So it's gonna be negative. Write and solve an equation to represent the solution, the situation. Okay, so let me see. Use S as a student. So S negative 9 over 10, so that's going to be plus S S 9 equal 1, so that's going to be plus 9 plus 9 plus 9 plus 9. So basically, I'm coming back to the same thing. So S is equal to 10. Oh, that's a negative 1, so that's 8. S equal to 8. So it's going to take an average of 8 and 10. So I get 10 and 8.
Perfect.
And then I have 8 is less than or equal to S, less than or greater to 10.
Excellent. That's perfect.
I mean, I've done this already, but I don't know why I'm not. That's one of the problems that I have. I probably need to buy back that pill. I don't need to rely on medication to have memory.
All right. So this is practice number 1 and practice number 2. We have done both of those as a class. So feel free to turn those in. You don't have to turn them in if you're live with me because I'm already going to give you credit for them. If you are watching this back, please turn them in by 7 o'clock tonight. Those of you who are with me right now, make sure you do practice number 3.
Okay.
Or the exit ticket by 7 o'clock tonight, okay?
Practice number 3.
Yep. Or the exit ticket. Okay? Either one of those need to be turned in by 7 o'clock tonight to get the afternoon credit for today. But that brings us to the end of week 5.
I'm gonna try the extra ticket because that one is showing me the charts with the 1, 2, 3, 4. I'm always having problem with that one.
Okay. All right, y'all. I will see some of you on Friday, and I will see the rest of you on Monday. Jules, you didn't take the math test. I didn't see it.
I will take it today. I didn't have time yesterday.
Okay, no worries, no worries. All right. Okay, have a good one.
I think my oh yes, Mr. G.
Yeah.
When I asked for the results when I did the test the other day.
Which test?
The test back to school. Oh God.
Oh, the CASAS test?
Yes. That
okay.
On the paper it said that I needed to retest.
Let me check. I don't think you do. I mean, let me go ahead and check right now. Let me stop this share.